get your attention, please. This is a fundamental relationship for chemical calculations. And for those of you who go on to do chemistry core, you use this over and over and over again. It's on your formula sheets. What does it mean? Well, lowercase n, this is actually the symbol then for the number of moles. Remember that the units then for moles is mole, M-O-L. The little m on top, we can think of this as the sample mass. And it is in grams. So lots of questions might say, you know, you've got 10 grams, or you've got 5 grams, or you've got however many grams you've got in the question. That's the sample mass. And the capital M on the bottom is the molar mass. And we can think of that in terms of grams per mole. How many grams are there in 1 mole? That's going to be the molar mass. Those of you who are interested in this from a mathematical perspective, if you think about the units, then these will cancel out. And because you're dividing by something to the power of -1, it's the same as just multiplying by it, isn't it? So this then is just the then equal to mole. Which is why the units work. Okay? So that is our equation. You don't need to know that, but you do need to know that the little m, you need to be able to use it. So n is the number of moles, little m is the sample mass, and capital M is the mass of 1 mole of whatever it is that you're doing a calculation on. And this formula is on the formula sheet. So if we look at our worked example, we were asked to calculate the number of moles in 4.63 grams of magnesium chloride. So the way you set this out is this is what we're trying to find. So in chemistry what we do is we write the symbol and then in brackets say what it is we're investigating. So moles of magnesium chloride is going to then equal our sample mass, which was 4.63, divided by the molar mass. And again, I'm not going to be able to find the number of moles until I know the molar mass of magnesium chloride. So I look up on the formula sheet, the mass of 1 mole of magnesium is 24.31, and then 2 lots of chlorine is 2 lots of 35.45, gives me then 95.21 grams per mole. So if I want 1 mole of magnesium chloride, then I'd have to weigh out 95.21 grams. But I don't have that much. What I actually have is 4.63 grams. So now, find my moles. It's going to be 4.63 divided by 95.21. 0.0486 moles. Yes. So here, now we've actually done a calculation. So this is a division. So we're going to be using sig figs. And we've got 3 sig figs given in the question, and so we've given our answer to 3 sig figs. Remembering that these zeros on the left-hand side aren't significant. They are just telling us they're placeholder zeros. It would depend on our units whether they're there or not.
But you wouldn't put 6 0 because it'd be 4.
Sorry?
You wouldn't put a 0 after 6 because that'd be 4 significant.
That's right, yes. So if I had a 0 on this end, then that would make it 4 sig figs. That's right. Okay, so there's a couple to try it yourselves, but before I let you do that, we'll look at this other formula which is also on your formula sheets. Now this is an unfortunate one because it says n equals n times n. I don't know why we couldn't find a few more letters, but this here, this capital N by itself is the number of particles. If I'm counting atoms, it'll be the number of atoms. If I'm counting molecules, it'll be the number of molecules. Okay, so it's just the number of whatever it is you're counting. N is the same. Our lowercase n is still the number of moles. And our units is still mole. But the capital N with the subscript A is Avogadro's number. Which is put on your formula sheets as well. So if we want to know the number of particles present in 2 moles, then I'm just going to multiply Avogadro's number by 2, and that tells me how many particles I had. If I knew I had 6.02 times 10 to the 23 particles, and I wanted to know how many moles I had, I divide both sides by Avogadro's number, and it will tell me I've got 1 mole. Okay, so depending on what you're trying to find, you can see there's a bit of a directional relationship, whether you're multiplying or dividing to go from one side to the other. So there's a worked example. Let's have a look at these worked examples on page 22. Okay, and the other thing is, how do we know which formula to use? If the question is asking about atoms or molecules or particles, then that's guiding you to this one here. If it wants to know how much, like as in how many grams or how many moles, then it's this one here. So our worked example 1, how many atoms are there in a pure copper coin weighing 2.56 grams? The relative atomic mass of copper is 63.6. Okay, what we're going to need to do firstly is find the number of moles, because we need this relationship here. If you're this way, if you're mathematically inclined, what you can do is substitute in this information for n, and just do the calculation in one step. So for example, n then would equal little m on big M times Avogadro's number. So all I've done is replaced the n in this one with this here. So I can do it that way, or you can do it in 2 steps. It doesn't really matter. But we wanted to know the number of atoms for copper. So we've got 2.56 grams, 63.6, and then we're going to multiply by Avogadro's number. 2.43 times 10 to the 22 atoms. Does that make sense? Or, like I said, you could also have done it as 2 separate calculations. So you can calculate n first, and then just multiply that by Avogadro's number. question, or worked example 2, what is the mass of 1.0 times 10 to the 12 molecules of sulfur dioxide? Now, what we need to do again is to find the number of moles. So if I'm using, I've been given molecules in the question. Again, that hint that we need to use this formula. So in this case, if I want to find the number of moles, it's going to be the number of particles divided by Avogadro's number, isn't it? If I rearrange this, again, I could put it straight in if I wanted to know the mass. So I want little m. Little m is equal to n times m when I rearrange that. So little m will equal that. If I substitute in, that way I could do it all in one go, or I can, as I said, I could do it in 2 steps. So my number of molecules is 1.0 times 10 to the 12, and I have to divide that by Avogadro's number, and then multiply it by the molar mass, which I do need to calculate. 32.07 plus 2 times 16. So my mass then would equal 1.1 times 10 minus 10 grams, according to assuming this calculation is correct. And we did need to express it to 2 sig figs because the question was given to 2 sig figs. Because it gave us a mass of 1.0 times 10 to the 12. So that's telling us to match that for our answer as well. Take great care when you're putting these in your calculator. I would suggest that you use the fraction button, because otherwise you could end up multiplying incorrectly. If you're not using the fraction button, then you must remember brackets, because if you don't do that, what you would end up with here is that calculation done by your calculator, which will give you the wrong answer. So just make sure that you either use brackets or better still use the fraction button. I think you do need to have a bit of a time to read and digest.